Hello guys, you're welcome once more to MEPH. If you are new to the channel, you're highly welcome to subscribe and share this link of this channel to somebody that it may be of help to. Alright, so today we have a problem on sequence and series. So let's look at the problem together. So the question says find the sum of infinity, okay, of what a geometric progression, okay. So that is a GP. Alright, whose first term? So our solution, we are given the first term, and most times we use what a for our first term, which is what 3 over 8 according to the equation, and our common what ratio, which we use as what r as what 1/3. All right, so now when we say sum of what infinity, we have different cases. We have case 1. For case 1, sum of terms is what we have a into what we have r raised to power n minus what 1 divided by what? We bring down r minus 1. Okay, this is a case where you have that what? Your r should be greater than what? 1. That this does not become 0. If r is 2, 2 minus 1 is 1. If it is 3, 3 minus 1 is 1. So r should be greater than 1. But if it is equals to 1, this becomes 0 and it becomes challenging to solve. Now for case 2, we have sum of what terms as the first term multiply, we are going to interchange this, so I have 1 minus the common ratio raised to power n divided by r, bring down 1 minus r without the power. Okay, that is for case 2. And in this case, our r should be what? Less than what? 1. So if r is less than 1, we can use the formula for case what? 2. Alright, so we also have case 3. For case 3, as n is equals number of terms times what? A, our first term. Now for case 3, the condition is that what? Your r is equal to what? 1. So when your common ratio is equal to 1, you want to use this. Now for case, okay, this is case what? 3. Now for case 4, we have sum of what? Infinity. Alright? So if we want to get the sum of infinity, okay, now for case 4, we have to come back to this, okay, such that we want to say this Rn approaches what? 0. That is the condition with which, we have sum of infinite terms, okay, for a geometric progression. So all I need to do is in this formula, I'm going to input this as 0. So we have a into 1 minus this becomes 0 divided by what? We are still going to leave this as 1 minus r. Alright, so the sum of infinity is going to be 1 minus 0 is 1. So 1 times a is a divided by what? We have 1 minus r. So we are going to use this formula to solve the problem we are being given. So let's impute the values of a, which is 3 over 8, and r, which is 1/3, into that expression. So we are going to get our sum of infinity is going to be, so we have 3 over 8, okay, divided by what? So we have 1 minus what? 1/3. So this gives us 3 over 8, okay, divided by this I can write as 1 over 1 minus 1 over 3. The sum of infinity is going to give us, we have 3 over 8. Now for this, we are going to use cross multiplication method to solve this. So this will times this and this will times this. So we are always going to start this way. So we have 3 times 1, which is what? 3 minus what? We have 1 times 1, which is what? 1. Okay, so all this divided by what? So we have 1 times 3, which is also 3. Okay, so this will further give us, we have 3 over 8. Okay, divide by what? This division. Okay, so 3 minus 1 is what? 2. Divide, we have 3. All right, so with that, we can now finish up the problem. So we have this as sum of infinity is equals to 3 over 8. This will change to times, and I'm going to rotate this by the rule of what division. So 3 goes up and 2 comes down. So if we multiply that, we are going to get 3 times 3, which is 9, and 8 times 2 is 16. So the sum of infinity of this geometric progression where the first term is this, and the common ratio is this, is 9 over 16. Alright guys, thank you guys for watching this video. Hit the like button, do well to subscribe to this channel, and share the link of this channel to some students, family member, or friends that needs to improve his or her skill in maths. I will see you guys in my next one. Bye.